In this lesson, we're going to be talking about operations of vectors and the three-dimensional operations. And we're going to do this the exact same thing, the exact same way we did two-dimensional vectors. So we have here, and I've gone ahead and written these rules out. If vector v is this and vector w is this, then how can we do scalar multiplication where k is a real number? Well, you simply distribute like you did before, multiply all three of these by k. How do you add two vectors? Well, you just add their components. How do you subtract two vectors? Well, you just subtract their components. So the exact same operations as we did before. So let's try some of these. Number one says to do 5a minus 2b plus c. So let's start out by doing 5a. So that turns vector a into, multiply everything by 5, that'd be negative 5, negative 25, and negative 15. That's 5a. Minus 2b. Let's go ahead and do 2b. And you can go ahead and distribute that negative 2 if you'd like to, and then add the two vectors, but I'm just going to go ahead and distribute the 2. That's going to be a 4, a 14, and a negative 20. And then you have plus vector c, which is 3, negative 4, and 9. Now, how do you add and subtract vectors? Okay, to subtract vectors, you simply subtract components. So this first vector minus the second vector is going to be negative 5 minus 4, which is negative 9. Negative 25 minus 14, which is a negative 39, and negative 15 minus negative 20 will be negative 15 plus 20, which is 5. And then we're going to add vector c, which is 3, negative 4, and 9. To add two vectors, simply add their corresponding components. Negative 9 and 3 gives you negative 6. Negative 39 and negative 4 gives you negative 43. And 5 and 9 gives you 14. And there is your final answer. Number 2 says to do negative 3a plus 7b minus 4c. So negative 3a, I'm going to distribute negative 3 times a. So that turns it into vector 3, 15, and 9 plus 7 times b. Here's vector b. That's going to be 7 times everything. Will be 14, 49, and negative 70. Now, it says minus 4 times c. This is the other thing I told you. If you want to distribute a negative 4, we could simply do plus negative 4 times c. So that's the second way you can do that. So let's go ahead and distribute negative 4 would be a negative 12, and that takes care of the subtraction. Negative 12, 16, and, let's try that again, negative 36. So multiply everything by negative 4. So now if you would like to, in the last problem, I did one at a time. I subtracted these two and I took that answer and then I added this. Or if you would like to, do all three at the same time. 3 plus 14 minus 12, or plus negative 12. That's 17 plus negative 12, which is 5. 15 plus 49 plus 16. That would be 64 and 16, which is 80. And then finally 9 plus negative 70 plus negative 36. That's going to be a negative 61 plus negative 36, which is a negative 97. Okay, on number 3, we're asked to do the exact same thing, except for they give our vectors as linear combinations, no big deal. We could actually change them back if you would like to into component form. 4x, if you would like to do 4 times x, that'd be negative 28, comma 12, comma 20, if you want to just go ahead and write it back in component form. Plus 3 times y, here's y, that would be 6, negative 3, and negative 18. So now you could write your answer in component form, or if you would like to write it back as a linear combination, let's do that. Negative 28 and 6 is a negative 22, and if you'd like to just put the I after it now. 12 and negative 3 is 9, so that'd be plus 9j. And then 20 minus 18 would be plus 2k. So there it is, written as a linear combination. The next one, negative x, you could also leave it as a linear combination. The only thing, it gets a little bit ugly with all the i's, j's, and k's. So negative x would be a positive 7i, a negative 3j, and a negative 5k. And then negative 5 times y would be a negative 10i, a positive 5j, and a positive 30k. And then 8 times z would be a negative 24i, and a positive 24j and a positive 8k. And then you're simply combining like terms. 7i, not my negative 10i, negative 24i would be a negative 27i. And again, you can see how component form just looks a whole lot cleaner. Negative 3j, positive 5j, and a 24j gives me 2 and 24 is a positive 26j. And then negative 5k, positive 30k, and a positive 8k gives me positive 33k. Okay, next up, talking about the dot product. And again, you're going to see the similarities as well. The dot product of two vectors in space is similar to find the dot product of two vectors in a plane. If your two vectors are given here, then the dot product of v times w is defined as v dot w is equal to a1a2 plus b1b2 plus c1c2. And again, this is the only new part. And just like before, the vectors are orthogonal or perpendicular only if v dot w is equal to 0, just like before. So let's do some dot products here. It says find the dot product of the given vectors, then determine if they are orthogonal. So only if they're 0 are they orthogonal. So here u dot v is equal to, we got to multiply the a's, gives you 18, plus multiply the b's, gives you negative 6, plus multiply the c's, gives you negative 12. Add those together and you get 0. Are they orthogonal? Yes. That means they form 90-degree. It's a three-dimensional 90 degrees, but these two vectors do form a 90-degree angle in space. P dot Q is equal to 4 times 0, which is 0, plus negative 7 and negative 5 is a 35, plus negative 10 and 3 gives you a negative 30. That gives you a dot product of 5. So are they orthogonal? No. Number 7, same thing as a linear combination. R dot S is equal to, make sure you do your eyes with eyes. Eyes with eyes gives you 18, plus j with j. There are no j's over here. So therefore, that would be negative 2 times 0, which is 0. And then 3 times 4, which is 12. That gives you a dot product of 30. So these also are not orthogonal. And then finally, number 8, A dot B is equal to 17 times negative 4 is a negative 68, plus negative 8 times negative 10 is a positive 80, plus negative 2 times 6 is a negative 12. When you add those together, you get 0. So therefore, yes, these two vectors form a 90-degree angle. Okay, notice on the next part, we're finding the angle between two vectors, and it says as with vectors in a plane. Same thing. If theta is the angle between two non-zero vectors, then the cosine of theta, this should look familiar, is equal to v dot w over the magnitude of v times the magnitude of w. The exact same formula we used before, we can use in 3D as well. So it says find the angle between each vector pair to the nearest tenth of a degree. So the cosine of theta, the cosine of the angle between these two vectors, is equal to, first off on top, we've got to find the dot product. That'll be negative 20 plus negative 6 plus 8. And that is equal to negative 26 plus 8, which is negative 18 on top, over the magnitude of u. And again, the magnitude is simply the square root of a squared plus b squared plus c squared. So that'll be the square root of 16 plus 4 plus 1. So that'll be the square root of 21 times the square root of, the magnitude of v, which would be the square root of 25 plus 9 plus 64. So that'd be the square root of 34 and 64, which would be the square root of 98. And you can multiply those two together if you would like to. You don't have to. But on bottom, if you were to multiply those together, you would get square root of 2058. And then it's just calculator work. Type this into your calculator. The cosine of theta is equal to that. So therefore, to move cosine over, we will simply do the inverse cosine of that. And that will give you that theta is equal to 113.4. Now, something that I shared with you in the past, if you would like to completely ignore, because technically there are two answers there. If you completely ignore this negative, again, type it in, it's going to give you a reference angle. So your reference angle, if you drop that negative, it's going to give you the first quadrant angle. Drop the negative, do the inverse cosine of 18 over the square root of 2058, and you're going to get, as a reference angle, 66.6 degrees. And we know that since cosine is negative, technically you have an answer in the second and in the third quadrant. So with a reference angle of 66.6, subtract from 180 and you do get this 113.4, but add to 180 and you actually get 246.6, which is the other larger angle that you get between these two vectors. So this is the one they're looking for, though, so you can just do that. So number 10, the cosine of theta is equal to, first off on top, the dot product of these two vectors, m dot n, that's going to be negative 32, plus 7 minus or plus negative 20. When you do those together, that's going to be negative 52, and 7 is negative 45 over the magnitude of m. So that's going to be the square root of a squared, which is 64, plus b squared, which is 1, plus c squared, which is 100. And that's going to be the square root of 165 times the square root of a squared plus b squared plus c squared over here. The magnitude of n is 16, 49, and 4. So that's going to be the square root of 69. We can type all of this into our calculator, and again, you have two options here. They're wanting the second quadrant, because since it's negative here, they're wanting the second quadrant angle, the angle between these two vectors. You don't have to give both answers. So if you just like to type this whole thing in, move the cosine over by doing the inverse cosine, you're going to find out the angle between these two vectors is 114.9 degrees. Number 11, same thing again. To find the angle between these two vectors, we're going to find the dot product first. So that's going to be 18 when you dot these. Negative 3 and 1 will be a negative 3, and 2 and negative 2 is a negative 4. So our dot product will be 18 minus 3 minus 4, which is 11, over. So already I see that I have an angle in the first quadrant because magnitude is always positive. So therefore, if your dot product is also positive on top, where is cosine positive? That's a first quadrant angle, so we know that we have an acute angle between these two vectors. And we can tell that, again, just by looking at the dot product. On the bottom, first off, let's find the magnitude of vector C. That's going to be 36 plus 9 plus 4. So that's going to be the square root of 45 and 4 is 49, so that'd be simply 7. Times the magnitude of vector D. That's going to be 9, 1, and 4, which should be root 14. Type this whole thing in our calculator, 11 divided by 7 root 14. Find the inverse cosine, and that will tell you that your theta is going to equal 65.2 degrees. And number 12, the cosine of the angle between these two vectors. First off, the dot product, 8 and 12 gives you 96. 2 and negative 5 gives you a negative 10. Negative 3, negative 9 gives you a positive 27. Combine those terms, 96, 27, that's 123 minus 10 is 113 over. The magnitude of vector V be 64, 4, and 9, which is going to be the square root of 68 and 9, which is 77, times the magnitude of W, which is 144, 25, and 49, 144, 25, and 81, which is going to be the square root of 250. Again, type this whole thing into your calculator now. Make sure to put the bottom in parentheses if you type it in all at the same time. Move the cosine over by finding the inverse cosine, and you find out the angle between these two vectors is 35.2 0.5 degrees.